So this is a game I made in Java where there are these bots that tries to shoot these trashes floating in space. Well, this one just died, but there are 100 shooters and you can use the arrow keys to flip through each one of them. Most of them are dead, but if the game didn't move on to the next phase, there's probably one surviving right now. Oh, here. I want to show you how this works. This is my first attempt at creating a genetic algorithm. I'm not going to show you the entire code, but I'm going to show a general idea of how this game works. Each shooter has its own neural network. The input for this neural network is just the information about these trashes. So for each trash, you take its size, the position, the relative x position, so the difference in x with the shooter and the trash, the relative y position, so the relative position with the shooter and the trash, the movement in the x direction, so this movement, and the movement in the y direction. Movement in the y direction. It collects these information for the nearest 6 trashes. Well, in this screen, there's only 5, but the entire input node contains information about the nearest 6 trashes. After that, all of this information goes on to the hidden layer. I think there are how many? Let me check. Yeah, it's of size 30, which is pretty small. So there are 30 nodes in the hidden layer, and there are 5 nodes in the output layer. The output layer is just basically the like how fast it should move in the x direction. So move x, how fast it should move in the vertical direction, move y. And this one is about whether it should shoot or not, because I don't want the bots to just repeatedly keep shooting. And this is shoot in the x direction. And the last one is, of course, shoot in the y direction. So earlier I showed that there are 100 shooters. And basically the idea is to choose the best shooters and reproduce them. So over here, you see this information of each shooter. Shooter 17 has score 138. Shooter 35 has 138.5. You would see the scores of all 100 shooters in order. So shooter 84 got the highest score last round with 1950.3. Also, you would see there's a seed. So basically, the seed is used to generate the enemies. The seed is set randomly, and it is set exactly the same for all the shooters. So all the shooters will get the same enemies. You may notice that there's a generation and iteration over here. The iteration is how many number of games a shooter would play. So each generation of shooters would play 3 games, and at the end of those 3 games, the best shooters are selected. For example, these two. And then these two are used to reproduce the next 100 shooters. So we would then have a bunch of new shooters that came from reproducing these two. This over here was one generation that played 3 games. All of these will be discarded except for the best two. The best two will pass on to the next generation. So these two will pass on to the next generation. And all of these will be replaced with the newly reproduced shooters. And then in this generation, the entire process will start again. They will play a game, 3 iterations. And after the 3 iterations, the average score will be used to select the best shooters. For example, let's say these two. And these two will be used to create the next shooters. If you look over here, you would see I have a variable called reproduction mode. So basically, I tried different modes of reproducing. I will go over them right now. Basically, there are 3 modes of reproducing. The first is just to select the best two, which is what I showed over here. When I use the word reproduce, what I mean is, let's say this is the neural network of the first shooter, and this is the neural network of the second shooter. Basically, there's a 50-50 chance a link value from one of these shooters will go to the child shooter. So for example, the link value of the first one goes over here. This process repeats for all of the links. There's a 50-50 chance for this link. There's a 50-50 chance for this link. It's 50-50 chance for this link. And there's also a mutation rate. So if you go back to my code, you may also see this mutation rate, 0.1. So that means there's a probability of 0.1 that a particular link would be newly created, not belonging to any of the parents. I'm just implementing a way a link might have mutated from one of the parents. Another way reproduction can be done is by cloning them and then mutating some of the links. So what that means is out of all the shooters, it takes the top 33%. So for example, let's say this one, this one, this one, and then it replaces all the losers with the neural network of the winners and mutates the neural net. So let's say it takes this winner. So in the next generation, this winner will survive and his neural network will go here and mutate a bit. His neural network will go here and mutate a bit. And maybe this shooter is gonna survive. This shooter is gonna survive. For this, it will have a mutated version of the one of the successful shooters. Same for these two. Successful shooter mutate, successful shooter mutate. There's also a third way. I called it the roulette wheel. So basically, it selects two shooters, but instead of selecting the best two, it selects a random shooter where a particular shooter will have a higher probability the higher score it has. So what my code does is adds up all the score. So in this case, it would be 416. The probability of selecting this would be 101 by 416. The probability of selecting this would be 20 by 416, and so on for all the other shooters. So it selects two shooters based on this probability and reproduces them like before. So that's the gist of how the reproduction part works. The next part I want to talk about is how the score is calculated. First of all, there is a survive tick variable which checks how many ticks the shooter has survived and divides it by 4 because I don't want it to contribute to the final score too much. So the tick score is added, and then there's a hit point which checks how many times the bot has actually hit the trash. This is the trash. If the shooter hits the trash, that's a hit point. And if it hits multiple, then that's a combo. So hit point, max combo times 2. If a shooter hits like 2 trashes, and then another time it hits like 3, then max combo would be 3. So max combo times 2. This is added, and there are also dodges. So dodge is like if a shooter is over here. Let me pick another. A shooter is over here, and then a trash is coming in, and then the shooter dodges the trash. That contributes to its score because I don't want the shooters to stay in one position. So that -1 times 2. I don't know why I did -1. And what? Oh yeah, the shoot point. So I don't want the bots to repeatedly keep shooting all over the place. I want them to pause a little bit, shoot again, and then pause a little bit and shoot again, and so on. So I do subtract shoot points if they shoot a lot. And of course, the score cannot be a negative value. This is basically how the score is calculated. And yeah, that's the gist of how my game works. If you guys want me to showcase some other programs I've worked on, I would gladly do so. But yeah, do leave a like and comment on this video.